ready? So we know the normal pH 7.35 to 7.45, CO2 35 to 45, and bicarbonate 22 to 28. Okay? So a pH less than 7.35 is an acidotic pH, and a pH greater than 7.45 is an alkalotic pH. CO2 CO2 less than 35 is going to be an alkalotic problem, and greater than 45 is going to be an acidotic problem. And bicarbonate less than 22 is an acidotic problem, greater than 28 is an alkalotic problem. Anything affecting the CO2 is going to be a respiratory problem, and anything affecting bicarbonate is going to be a metabolic problem. What we need to remember is that CO2 is an acid. So the more acid you have, you're going to have an acidic problem. Bicarbonate is an alkaline. The more bicarbonate you have, you're going to have an alkalotic. So the less bicarbonate is going to be acidotic. If you have lots of CO2, you have an acidotic problem. If you have lots of bicarbonate, you have an alkalotic problem. Okay? So when CO2 is out of range, we are having respiratory issues, and when bicarbonate is out of range, we are having metabolic issues. Okay? Next thing. The steps to solving your ABG, the very first thing you want to look at is your pH. We know that the normal range is 7.35 to 7.45. Anything less than 7.35, we are having an acidic problem. Anything greater than 7.45, we are having an alkalotic problem. Step 2, you want to look at CO2 and see, is that moving in the direction of the pH? So if the CO2 is following the direction of the pH, then we're going to know that it's a respiratory issue, and then we call it what the pH is falling under. So for example, if we have a lot of CO2, we know CO2 is an acid, and we have a low pH, that is going to be an acidic issue. We're going to know that we're having a respiratory acidosis. If we have a lot of bicarbonate, we know that bicarbonate is a metabolic issue and it's an alkaline. So if we have a high pH, we know that we are having an alkaloric problem. So then that's going to be a metabolic alkalosis. So we look at the pH first, then we look at the CO2 to see are we having a respiratory problem, or the bicarbonate, are we having a metabolic problem. Okay? So then we think about compensation. There's level of compensation. The first level is uncompensated. That means we have the pH that's telling us whether we are having an acidic problem or an acidic or an alkalotic problem. Then we look at the CO2 to see which one is following the pH, CO2 and bicarbonate. Whatever's following the pH, either in the acidotic or the alkalotic side, then we know we are having that issue. So for example, a pH of 7.19 is acidic. CO2 of 52 is a lot of CO2, so it's acidic. Bicarbonate is 23, which is in the normal range. So there's no compensation going on. So this ABG is uncompensated respiratory acidosis. Okay? Then another example that we can have here, pH of 7.47 is an alkalotic problem. CO2 of 42 is in the normal range, and bicarbonate of 31 is alkalotic. So we know that this is an uncompensated metabolic alkalosis. Are we together so far? So the next step that we are going to have now is partially compensated. So when an ABG is partially compensated, it means that the buffers are working, but the pH have not gone back to the normal range. So pH is still out of range. Range meaning 7.35 to 7.45. So the pH is not within this range. So for example, if we have a pH of 7.34, we have a CO2 of 56 and a bicarbonate of 33, we know that this is a little low, so it's going to be an acidic problem. CO2 of 56 is high, it's acidic, and bicarbonate of 33 is higher in an alkalotic state. So bicarbonate is starting to increase because it's an alkaline to correct the respiratory acidosis, but the pH has not gone back to the normal range, 7.35, 7.45. It's almost at the normal range on the lower side, so we know it's an acidic problem. So this is going to be partially compensated. Respiratory acidosis. Because the pH is still out of range. That's why it's partially compensated. What makes it fully compensated is when the pH goes into this normal range. We are not there yet. So another example, I'll use a different color. pH 7.46, CO2 of 34, and no, pH, we're going to do CO2 of 50, and bicarbonate, let's do bicarbonate of 32. Okay, so in this example, we know the pH is 7.46, so we have alkalosis. CO2 of 50 is high, so it's acidic because CO2 is an acid. Bicarbonate is high, which we're going to know we have alkalosis because bicarbonate is a base, it's an alkaline. So this pH, because 7.46 is alkalotic, but it's on the higher end, we know it's trying to become normal. This alkalosis follows the pH. So now we have partially
Good morning, ladies.
good morning, compensated. We know it's metabolic because of the HCO3, metabolic alkalosis. In both of these problems, they are partially compensated because the pH is trying to drive back into the normal range, but it has not gone back normal. Both ranges are out of range, but we see that in this case here, we have an acidotic problem. Thank you. We have an acidotic problem, and the issue here, CO2 is an acid, so that's following the acid. So even though bicarbonate is working hard to bring it back into the normal, pH has not reached the normal range yet. And then on this side, alkalotic problem, and CO2 is working hard to bring the alkalosis back to normal. We are almost there, but we are not there yet. So that's what partially compensated is. Are you guys okay so far?
Yes.
Let me show you are fully compensated. Did I run out of those things? Yes, yes, yes. 1 second. Sorry, we are making a video for Blackboard. I'm almost done.
I hope I'm not in it.
You're not.
You're not.
Okay, thank God. I don't look cute today.
Okay. Here we go. Okay. This is what happens when you're a hoarder. You have so many things.
When we come
So,
back.
5 minutes. Sorry about that.
Don't even miss it. If not, I can come back at the end of the day.
Okay, I'll be here all day, but you can come back. 5 minutes, I'll be back. I promise.
I'm gonna go eat.
Or 2 minutes. Okay, go eat. And then come back. Okay. So fully compensated means that the pH has returned to the normal range. (7.35 to 7.45). That's our normal range. So the other values are going to be off, but the pH has gone to the normal range. So for example, pH, we're going to say a pH of 7.36, CO2 48, and bicarbonate of 32. So we see the pH here is normal. CO2 is acidic. And the bicarbonate is alkaloid, out of range. Now, these two are out of range, so you might get confused. How do I know which problem we're having? When you look at the pH here, 7.36 is normal, but it's normal on the lower end, meaning this used to be an acidic problem. So now we look at the other ranges and see what is acidic. So this becomes fully compensated, respiratory, acidosis. And it's fully compensated because the pH has gone back to the normal range. It's within the 7.35 to 7.45. Do you guys get that? And then if we had a pH of 7.44, CO2 of maybe 33, bicarbonate of 19. We look at the pH, it's normal. CO2 is 33. We know CO2 is an acid, so if we have less of it, we know that we are having an alkalotic problem. And then HCO3 of 19. HCO3 is an alkaline, so if we have less of it, we know it's trying to become acidotic. So when you look at this problem, we decide that it used to be an alkalotic problem because it's in the normal range, but it's on the high normal. So it used to be an alkalotic problem. It's gone back into the normal range, the pH. So now this is a fully compensated respiratory alkalosis. You get that? So even though the two ranges are moving, we look at what is it closer to for us to determine what the problem is. And then I'll do two more for the metabolic. Thank you. So here we're still going on with fully compensated. pH has to be in the normal range. So a pH of 7.36, CO2 7.36, CO2, we're going to have a CO2 of 32, and bicarbonate of 7.20. pH here is normal. CO2 right here is low, which we know is alkalotic because CO2 is an acid. So the less of it, the more alkalotic the blood. And an HCO3 of 7.20 is low, and HCO3 is an alkaline, so we know that this is an alkalotic. No, it's an acidotic because HCO3 is an acid. So the less of it, the blood is more acidic, so acidotic. So then we look at the three values right here. We know the pH is normal, but it's normal on the low range, so we know it used to be an acidic problem. So we look at what is an acidotic problem, and here, because it's gone back into the normal range, we have a fully compensated metabolic acidosis. And it's fully compensated because the pH has gone back into the normal range. That's what tells us whether it's fully, partially, or uncompensated. And then the final example that I'm going to do is so for fully compensated, so we're going to have pH of 7 0.44. CO2, we're gonna have maybe 47. And bicarbonate, we're gonna have a bicarb of 32. So this is normal, but it's normal on the higher range. So we know it used to be an alkalotic problem, because normal is 7.35 to 7.45. So that's normal. CO2 of 47 is acidic because CO2 is an acid. And bicarbonate of 32 is an alkaline. So we know the blood is more alkaline. So here we determine that we are normal, but we are normal on the higher range. So it used to be an alkalotic problem. CO2 of 47 is acidic, so we know it was not a respiratory issue. So bicarbonate of 32 is an alkaline bicarbonate. So now we know that this is a fully compensated metabolic alkalosis. So it's fully compensated because it is in the normal range for the pH. And then we know it's not a respiratory issue because the CO2 is acidic. It's trying to correct the alkalosis. And the bicarbonate, we have more of it and it's an alkaline. So it's fully compensated metabolic alkalosis. So steps, we always look at the pH, what is following the pH, and then we proceed from there. And that's it. Okay? So I'll put